Hey there. Hi everyone. My name is Repo. I'm on the Azure Global Black Belt team and I cover developer experience and platform engineering. This is a series about machine learning development experience and how to actually get the most out of your developer environment and how to get started very quickly. The series overview, at least for now, will consist of 4 topics, or essentially 4 videos. Topic 1 will be MLFlow and GitHub Codespaces. Topic 2 will be about creating a remote tracking server with MLFlow. And then topic 3 will be about connecting to the remote tracking server. Topic 4 will be about shipping your actual machine learning model to production. Just as a disclaimer, I may change up the order or add topics as I go, but I'll update the overview, this video, as I go along if I actually make any changes. With that said, this will be topic number 1, MLFlow and GitHub Codespaces. So for this video, we're going to talk at a high level what MLFlow is. So it's not going to be a deep dive on MLFlow, just enough to get started if you're not already familiar with it. Hopefully you are. I want to talk about what dev containers are and how that relates to something called GitHub Codespaces. What I want to do in this video is to show you how to actually create a quick start environment that already has MLFlow installed on there, how you can actually use it as a local development environment, even though Codespaces is actually a remote service itself. How do you connect to Codespaces? How do you start it up? How do you create it? How do you actually run an MLFlow server locally, which by locally again, I mean inside the GitHub Codespace itself. How do you actually run an MLFlow experiment or project? And then how do you view those experiments, the subsequent runs of your experiment, and then save those results to GitHub Codespaces itself so that you can share or rerun the experiment at a future time. Okay, so let's get started. So this is MLFlow, just at high level. It's mlflow.org. It is a project, you can call it a platform, and it also includes a library that has been created by the good folks over at Databricks to help manage your ML ops itself. So machine learning operations, so allows you to run experiments, write the Python code with whatever AI ML library you actually want to use under the hood. So it could be scikit-learn, it could be TensorFlow, list goes on and on. It allows you to essentially run each of those experiments and leverage one of the most important components is leverage the MLFlow tracking server, which will then kind of track, as the name implies, all of the parameters that you are using. Allows you to log or store or save artifacts, which includes your model itself, the Python requirements, etc., and allows you to share that with peers or folks in the broader community, and to rerun the experiments at a future time if you wanted to further change values for rerunning the model or for retraining it, etc. For this series, the core components that we will be talking about will be experiment tracking, so that tracking server itself, the model registries going on, and then serving the actual models at the end of the day. I would highly suggest that you go through this. There are also a lot of great tutorials, even from the good folks at Databricks. Have a video which I'll list in the comments below or the description below. A 2022 talk about using MLFlow and what the overall ML ops sort of workflow would look like for your given environment. All right, with that being said, again, just going a little further in documentation, core components of MLFlow, tracking, model registry. We're not going to cover LLMs in this series, and projects will be sort of the core things that we will discuss and how to actually get them set up in your environment. All right, the next thing I want to talk about in this video is development containers or dev containers. It is essentially a metadata specification configuration file wrapped around your Docker file, Docker Compose file, or perhaps a Docker image that allows this development containers CLI or runtime, or however you want to see it, to further configure an existing container to include additional customized coding tools or libraries that you may need to run inside your development environment. At the end of the day, what we really want to get out of this is a quick start environment. And one of the values out of this is it actually provides a facility for you to inject additional tooling inside a VS Code environment. So you can run this locally on your machine. You can run this in private public cloud. You can run it on a remote server if you're running it there. Kind of like how you have VS Code server. You can run sort of that connected environment any which way you want. This comes or can be configured with a VS Code server environment, as I mentioned before, but in the sort of the web fashion, so that you automatically get an IDE in your browser instead of having to install VS Code locally on your machine. That particular implementation now brings us into the concept of GitHub Codespaces. So on the GitHub Codespaces side of things, it is a service inside GitHub. You can buy it in, or it is included if you have a full-on GitHub account. It starts with, I believe, 60 hours a month of free Codespaces usage. That usage, of course, varies depending on the size of the compute that you want to use behind the scenes. And essentially, this deploys a dev containers instance behind the scenes, wrapped, of course, with some additional platform-specific implementation from GitHub that allows you to, through the UI, pick, again, the VM size, the container, essentially is a container behind the scene, container size, and automatically adds a GitHub pat token into the environment so that you can start doing git pull and pushes from the repo that you're deploying Codespaces from. It also allows you to, via the VS Code configuration in your dev container JSON spec, to pre-install, or that is to say automatically install once it spins up, additional VS Code extensions. So you might want the Docker extension, Kubernetes extension, Terraform, GitLens, whatever you would normally install as an extension inside your regular desktop version of VS Code. You can do so inside the Codespace. And it will also automatically provide to you, if you want to deploy it by default through this manner, the web version or the VS Code server environment so that you can open up fully in your browser. All right. There are additional features. I highly suggest that you check out Codespaces more. And I will very much do a separate series about Codespaces and how to integrate that into your either CI/CD pipelines or DevOps in general, or even some development environments for, say, if you're a system administrator or platform engineer in the future as well. All right. Okay, so with that said, the next part of this, I'm going to now talk about MLFlow. Here is the site for MLFlow, for the MLFlow example. It's been around for a while, so I'm not actually 100% sure if this is like the de facto example. It's the one that I typically go to get started. It's got everything that we need. Typically, this shows a MLFlow project by default, ML project file itself, which, if you're not familiar, specifies the name of the project, what file you can use to automatically install all your requirements from a conda perspective. So the conda YAML file usually included. This is pointing to the one that's included in this directory. And then main entry points. What are the parameters that you would be passing into your command, and then what command are you actually running, and then you can interpolate the parameters accordingly as a basic example. And then the actual conda file, again, the requirements to actually install what you might need in your Pi, or your your Python environment, but here it uses conda. In this example, it will automatically install into your project when you run it. NumPy, the version, pandas, scikit-learn, pip, and then via pip install MLFlow as well. I'm going to show you later on in terms of my MLFlow Codespaces sort of quick start environment. MLFlow will already be installed, so that step probably be skipped over when you actually run the project because it'll be there in the environment. Lastly, this project also includes the actual Python file to which this will run an experiment with. If you're not familiar with MLFlow, and the reason why I'm walking through this quickly is to show that, MLFlow is both a platform as well as, in my opinion, like a library or a convention of writing, because it provides this framework for you that is included with the MLFlow library itself or package. The capability of doing some things like actually running the MLFlow experiment run with this method start run. And inside of this allows you to log things like the parameters that you're running for the experiment. So you can rerun this and pass different values. And when on each subsequent run, so each of these parameters, alpha, L1 ratio, root mean square error, if I'm not mistaken, RMSE, R square, and MAE, these values for each one that gets passed in gets saved and logged to the MLFlow tracking server, which is part of the platform piece of MLFlow that allows for every subsequent run that you do to track exactly what you did for that, so that you don't have to write in on a post-it or however you're tracking it, or in some other way. You know exactly what happened during that experiment. Did it succeed? Did it fail? It also provides you with the UI components of it to see and track sort of if you've done multiple iterations of this within the experiment, where all of that tracks through. And then at the end of all of this, of course, we want to generate a model. In this case, it'll be a scikit-learn model. MLFlow has an understanding of how to work with a scikit-learn, how to produce that. And when we say log model, it's actually logging the scikit-learn model, and we name it model here, into that tracking server. And it'll be put into the model registry. So if it was a good model, we actually want to deploy into production and it's already baked or whatnot, then we can actually reference that model accordingly and then redeploy as needed going forward. All right, so that's MLFlow in a nutshell. I'll probably do a subsequent series or around this to have a little bit more of a concrete example. But there are lots of great videos on YouTube tutorials on how to get started with this. Caveat, I am not a machine learning engineer, scientist, or whatever the title for that particular role is today. And so my perspective will be more of a traditional backend developer getting into this, and also as a platform engineer or system operator on how to actually deploy and manage models going forward. So perhaps more of an ML ops engineer perspective on this. All right, on to the next part, and where I'll spend most of my time in this video is the actual MLFlow Codespaces demo environment. This is intended to be an example implementation on how you can take advantage of Codespaces for your machine learning or even data analytics workflow. It'll be needed to be modified for data analytics because this, again, is very much specific to MLFlow and getting it started. What I wanted to start off to show you is that we're taking advantage of the dev container specification, so that .dev container directory, and inside of that, as you'll see, has the Docker file that we're going to reference, as well as the dev container.json file, which is sort of the outer wrapper metadata configuration about how we're going to take advantage of the Docker file, which creates the underlying Docker image. As well as you could replace that with Docker Compose, or in our case here, we're going to just take advantage of a pre-built container image in our GitHub repository. What we have here, let's see, let's just jump into dev container.json file. Well, this is a fairly slim basic specification from a dev container perspective. We've named this particular dev container configuration. This repository was named something else previously, and I changed it to MLFlow Codespaces. Before it was named RK for my initials, GitHub MLFlow Local. I should probably update this. But that being said, this is arbitrary. So you can name this anything that you like. Hopefully something that makes sense to you and your peers or whoever you're sharing this with, and accordingly. Here, instead of specifying a Docker file and building this dev container on the fly each and every time I create a dev container, I am instead going to leverage a pre-built dev container that I made in my in the same repository under GitHub Actions, I generate a new container and save it as a container image in the GitHub container registry, which is part of GitHub packages instead. The reason being is because the container image itself could take minutes to create, whereas leveraging or pulling down a already pre-built container image is much faster. And very likely for your scenario, as you build this out and you start customizing this container image, the image will get larger and larger. I think at last check, this image itself is, I think, hovering around like 800 megs to maybe about a gig, which, isn't massive, but it can add up. It could be smaller, I could optimize it more, but that's a fairly good size. If I were to, again, switch this to the Docker file configuration or maybe Docker Compose configuration, when I create a Codespace, which I'll show in a moment, again, it'll recompile or recreate that container image each and every time. So that may take a long time to spin up. I can also add in ports to forward automatically from my Codespaces environment, or you can think of it VS Code server, remote server environment, directly onto my machine, such that I can treat this like localhost. And in fact, in the demo I will show in a little bit, it will feel very much like a localhost, even though it is a remote environment. So those ports automatically get mapped. Port 5000 is the default port when you spin up an MLFlow server or MLFlow UI environment, the tracking server. I've added port 8080 in here, even though I don't really use it, just as an example of this is the format in which you would take in order to add additional ports to forward to the remote environment. The customizations portion of this, we can go on, but the key thing here is it allows you to install out of the box or right away for you when you create or spin up the environment, the VS Code extensions. In my particular case, I've included this REST client. We won't be using it for this demo, but if you're used to Postman or running curl commands in the terminal, this particular REST client, this humau.rest client, is an extension you can install on your local VS Code setup. This will be included automatically and allows you to write files that you include in your project to, again, make get, post, delete, patch, put the whole HTTP request situation to your remote environment as you go along. So it's easy to test in that inner dev experience, inner DevOps loop that you may be accustomed to. Secondly, I've also included, this is an oddly named tool. It's called MS.NET Tools .NET Interactive VS Code extension. This is also known as the Polyglot extension, so Polyglot Notebooks extension. So you may be familiar with Python notebooks or Jupyter notebooks, something along those lines. The Polyglot experience or extension itself provides very much a similar Python Jupyter notebook experience, but across multiple languages. So if you've got C#, I think it includes JavaScript and a couple other programming languages in there, you can run that inline within the same notebook, as opposed to like Python or Jupyter, I believe is very much specific to Python itself. So that's the main difference and why I included that. And then lastly, even though again we're not going to be interacting with Docker, just to round this off and show you some of the other extensions that are there, the VS Code Docker extension by Microsoft as well, included when we spin this up by default. For the most part, I'm going to, instead of working directly in this environment, I have already, and I will be working from a forked version of this in my own repository here. But for now, we're going to stick to the MLFlow Codespaces repository inside the Dev Experience GBB organization in GitHub instead, just for a few more minutes. A couple of things I wanted to show before I show how to create the Codespace. First and foremost are actions. So if you're not familiar with actions, hopefully you are, give it a try. There are a couple free, or there are, I forget the exact value, but there are free minutes every month as well that you can leverage. There are more if it's a public or open source project itself, and then private, of course, it's a little bit limited because at that point you'll probably have to have a billing vehicle of some sort in order to get additional compute hours for running. But depending on the size of your project, the free minutes will probably be sufficient for most needs to get started. The main one I wanted to show is the dev container image build action. So if you're familiar with other CI/CD tools, automation runners, goes by another name, is basically a, let's call it a virtual machine, even though it's probably a container, or it is a container environment behind the scenes, that runs a scripted set of automation tasks. And this particular setup is defined via a YAML file. Future videos, lots already exist out there on the syntax, the specification of GitHub Actions itself, or GitHub Workflows. And you'll notice that we have ways to trigger our pipeline or workflow. Dev container image build, which is what this is going to do. It's going to build the base dev container image. It's going to trigger on manual triggers. So workflow dispatch is a way to define, I can manually just trigger this whenever I want inside the web UI here in GitHub. I can also trigger it on push on specified branches, main in my particular case, and only when certain files have been updated. So in my particular case, I only want this pipeline to run when the Docker file has been changed or updated. I can also trigger on pull requests. So if another teammate decides to change the Docker file or the specification, because again, I've pinned this trigger to a pull request, but only if the Docker file has been updated, and only when the pull request is done against the main branch. All right. Continuing on with this, you probably see similar things in your tool of choice, or if you're familiar again with GitHub. We're going to check out our given repository. We're going to define here, in this case, parameters. So there are some things that you may need to sort of massage in terms of data. This particular step is modifying the GitHub repository name to lowercase, because when we build a container later on, the container registry only likes names with lowercase, no capitalized, no camel case, no Pascal case, just straight flat lowercase characters. And so I had to take the name of the repository, you see here, dev experience or XP GBB. I've camel cased this, and as a result, when I originally ran this, I had to run GitHub script to change or modify that to all lowercase, and then set that as an output that I can reuse in subsequent steps or jobs in this given environment. All right, that being the case, through here, again, I check out the environment. I can run the GitHub action to actually run a Docker build, and had a pause momentarily there, cough. I've got the Docker build step or action here, which allows me to have the Docker CLI available to me, allows me to run subsequent steps to add metadata about the container I'm about to build, what I'm going to name it, where I'm going to store it. So here, GitHub container registry IO, and then the owner of the container, which is one of the values that I set up here. And then I've named this dev container base. This is statically put in here. You could change it with a variable or environment variable, but I've just decided statically to put that container image name there. This also allows me via my GitHub tokens, which this environment automatically provides for me the capability of using GitHub tokens for my actual workflow itself, which is a separate identity from myself. It actually identifies itself as the pipeline. It has a scope token, which you can add additional permissions to depending on what you're trying to achieve. In my case, by default, it has the ability to write to itself. And then I can push the container image to the GitHub container registry, where ultimately it will be stored. And what we will see, if I go back to MLFlow Codespaces, we'll see packages, is just where the container gets stored. So other packages could be NPM packages, could be Ruby gems, NuGet, list goes on and on, can be stored in here. This is the container registry version of it under the hood, and it shows you, how many times you've been downloaded, has it been downloaded and used. It's a good way to track some stats and what have you, and also includes the README of your project as well. Okay, great. So I've got this container, this dev container base available in here. I went too quickly there. I can pull this image down to my local environment to take advantage of and use right away, which is, in fact, what goes on in this dev container JSON is I'm referring to that particular container image. and pulling in the latest one that's been built each and every time. I could pin this to either the long SHA or the short SHA of the container image. That's possible as well, but I've just chosen to do the latest here. Okay, so that was the building the container image pipeline so that I have it available to me that I can use, and this has been made public container registry. I can use it anywhere. You can take advantage of it as well. I use it in my dev container, so when I create a dev container, it automatically uses that image. If I click code here, I'm just gonna go back to local. You're probably very used to this kind of workflow, right? I will git clone the repository itself. In my case, in order to start my development process, instead of cloning it to my local machine, my laptop here, or desktop, whatever you're writing on, I'm going to choose to instead spin up a GitHub Codespace, which you can think of as an ephemeral environment. Sometimes it's tough to say, in GitHub itself. And the reason I personally really prefer this, and I'm starting to move towards this model, is that I could be working on a machine that's actually quite, for lack of a better way of saying it, polluted. Like I've got a lot of different languages, packages, repositories, versions of Python, etc. While there's, Python environments that you could run or virtual environments that you can run. You can use Conda to help manage that. I kind of find that they get a bit clumsy and sometimes I forget to switch, even though it clearly states which environment I'm in the command prompt. Things happen. So the Codespace path to me feels a bit cleaner. I don't find that there's a experience difference because the connectivity to the Codespace itself is actually pretty smooth. And we're talking about, depending on where you are, where your Codespace is being deployed to, we're talking about maybe at most low double-digit millisecond latency. And if you're working on a terminal, you'll likely never see any of that anyway. All right, so I digress. I really enjoy the environment, and I think it's a great way to start up because we can share the repository and all the configuration and spin up a Codespace with peers whenever we'd like. By default, you can just hit this plus sign, or if you don't have any Codespaces, I have some already deployed, you hit create. There'd be a green create Codespaces button down here, or hit the plus sign to create one on this particular branch. In my case here, I'm just going to show you the more advanced or more complicated or more configuration things that you can clicky pointy choose to go through. I can choose a different branch. I don't have any other branches on this particular repo, but let's say I have a feature branch or a development branch or a staging branch that I want to deploy the code in that branch instead of the main branch. I can choose the dev container configuration file that I want to leverage. So inside that .dev container, I can choose multiple. I can create multiple files in there, name them different. You notice this RK GitHub MLFlow local name here corresponded to the name of the .dev container JSON file that I had a second ago or a few minutes ago open. So that matches up. Okay, so this will just enumerate or list through all those dev container files with the name accordingly. I can choose to deploy in these 5 regions today. Okay, so again, as I mentioned before, your experience may vary. If I'm based out of Toronto, if I just deployed a GitHub Codespaces environment in Australia, I'll likely be noticing probably like triple-digit millisecond latency due to physics, right? And then I can also choose the machine type that is running behind the scenes. 2-core all the way up to 16. I think I can get past that to 32, depending on the environment or the license that I have. You could probably open up a support ticket to ask for larger machines as well. I have seen that with some customers, though I haven't experienced firsthand on how to actually do that, but it is possible. That being said, I can spin up a 16-core, 64 gig RAM, 128 gigs of storage machine in VS Codespaces within minutes, right, at the most, depending on the size, again, of your dev container, very, very easily. So this is another big reason why I would say, be familiar with Codespaces. Is it the silver bullet solution for what you're trying to do? Probably not for some cases. But if you're like me, I'm on a MacBook Air at the moment, which is a great machine. it may not be powerful enough to run what I'm trying to do in the end. So I have the capability of spinning up this environment on the fly, right? So whatever I choose to do here, I want to, let's go with 16 core, why not? I can hit create code space, and the default experience here is that it will spin this up as a web browser experience. You'll notice that automatically I get VS Code kind of spun up by default, this web server version of it, a VS server environment. And I can, once this spins up and it's building, it's pulling down the image that I pre-created, it's installing the extensions, etc. I can start coding right away. Okay. This particular environment doesn't have an MLFlow project. We'll run through that and how to go about it. And then we'll also go through the traditional sort of, git add, git commit, git push kind of workflow to add that project back to my repository. It's connecting, and that took, I don't know, I'm just gonna make a guess. That was like, what, 2 minutes, 3 minutes to spin up a pretty large machine, 16 core machine. And it's got my entire repository already kind of spun up for me. You'll notice that it pulled in the whole repository, including the dev container. So if I want to modify the dev container spec in here, and I want to use that as my development environment for that, I can do so. I can edit the Docker file. I can edit my GitHub action workflows. We've got a docs file in here. I'm not going to enumerate through everything. You're not here to watch that, but basically I can do that all here. I am going to close this though, because I don't want to push things back to my demo repository, because this is supposed to be blank for other folks to leverage as a base. I'll probably change this to a GitHub repo template shortly, so that you can just spin it off instead of having to fork from it. Okay, so I'm going to close this out. And before I move on to actually run the MLFlow project, I'm actually going to click back here instead. I am just going to show the action to actually create a Codespaces prebuild. So you might have noticed earlier, if you're super observant, then when I hit the machine type, you'll notice this lightning bolt and then prebuild ready. This is basically speeds up the build of the environment even further, so that 1-2 minute creation time. Not only am I leveraging a pre-built a container image that's stored in this container registry that's in GitHub, I can also create a pre-build in a given region such that a lot of the pieces that it would normally install as well when you create the Codespaces, even if I am leveraging a pre-built image, it'll do for me in advance. And what I wanted to say about this is a couple things. One, how do I enable pre-builds? So on your given repository, you can go to settings. I can go to Codespaces. I can go to some Codespaces pre-build configuration. I can set up a pre-build. Once I do that, let me hit edit. What it actually does behind the scenes for me, and there are things I can configure about this, like which configuration file for this particular pre-build do I want to leverage? Do I want to pre-build each and every time I push code to my repository? I would probably say not, because you got your project code, and then you've really got your dev container configuration. And instead, only run another pre-build or only trigger another pre-build setup if my configuration file itself changes. So that includes the dev container JSON file that I specify up here, as well as, I believe, the Docker file. I scratched that. It's just the dev container JSON file, because going on memory, I did that with the Docker file itself. I've changed it. It does not trigger another pre-build in here. So scratch that. Just the dev container JSON file that I specify up here. If that changes, then it will trigger a pre-build. I can also choose which region to have this pre-build deployed into or saved to. The reason being why you want to do this is because if you don't operate out of any of these other regions, the way that pre-builds work is that there is a cost to it. It's relatively minimal, but it is storage cost for essentially the container build or the wrapped, fully dev container JSON metadata wrapped build environment of that codespace, that storage is charged to you. And so as a result, if I don't work in any of these other regions, I'm localized perhaps East US or perhaps one other region, maybe Europe West or Southeast Asia, you name it, right? It'll only pre-build and store in those locations and keep my costs even lower than it already is. I can also, do things like, how many of these template versions to store, and then also if a build fails, who do I notify to let them know that something has gone wrong? Some scenarios for this, and I ran into this myself, is that when I changed my repo name, that also changed my my container image name as well, and I couldn't reach the pre-built container image because the repo name changed. A lot of things can go wonky. So this will alert if the pre-build fails because you might have done something silly like I did and changed the name without changing the configuration file, etc. It's good to get notified. I'll just leave it at that for now. Okay. What does this do behind the scenes for me? This is the UI to sort of get this done, but ultimately under GitHub Actions again, you'll notice I've got this Codespaces Prebuilds workflow. This is managed and maintained by GitHub itself. So it doesn't manifest itself, if I recall correctly, if I go back to GitHub workflows, maybe it does. No, it does not. So this is where GitHub workflows or actions get stored, the YAML file for them. In my case, under actions, you notice that build container one corresponds, I should name it probably better, but corresponds to this dev container image build workflow. All right. This Codespaces Prebuilds workflow is not included in that directory. This is all hosted and stored inside GitHub itself, but this itself reflects the actual workflow that runs my pre-build process. So I can see it run in here as if it were one of my own actions. I can see if it failed, where it failed, error outputs, etc. But I don't necessarily have control, at least today, it is a beta feature. I don't have control over the underlying YAML file that defines all of this for me. All right. Cool. So I wanted to get that out of the way, at least to talk about, what is MLFlow, what is a dev container, work my way to Codespace, how can you take advantage of Codespace for an MLFlow project or environment, okay? I hope that you investigate this a little further because this is, again, to me, a very invaluable tool to take advantage of, even if it's not for machine learning. If you're, back-end, even a web developer, you can actually connect to that remote environment as if it was local. So you can do like localhost port 8080 and then run like a React app in that remote Codespaces environment and update the front end UI, anything that your heart desires in that sense behind the scenes, okay? And connect to it through SSL, TLS, in your browser as well, okay? Probably a future video on that. Okay, I'm gonna move on to the next subject and talk about actually running my MLFlow project. So here, I don't have a Codespaces spun up. We'll spin another one up in a second. I've forked, as you can tell by all this information up here, I forked my demo repository under dev experience GBB, MLFlow Codespaces. I forked that. So it's one fork. I am the only person who's forked this as of today's date. Hopefully I'll see other folks taking advantage of it. Into my own personal account here. And this is where I'm going to actually run a demo example project in the Codespace environment. All right, let's do this from scratch. Let's do this live. Okay, so Codespaces, I want to create a new one. I'm not going to hit just create because by default it'll create the 2 core environment for me. I'm going to supersize my environment just for burning through this cache that I've got, this entitlement that I may have in my account. You'll notice that it's found the image that I specified in the .dev container, which is pulling from my Git repository. This one, if everything goes right, it's going to pull this one. This is public. It'll take this container image. It'll quickly pull it in. It'll build all the other material around the container. So the extensions, the Codespaces wrapper environment, injecting the pat token into my code space so I can do git pull push right away inside the environment. I can also see the logs. You'll notice that it's downloading. This is a lot faster, I would say. You may want to run an experiment yourself around this, where it's pulling in the container image as opposed to building from scratch from the Docker file, which you might know from experience that with Python and all the dependent libraries and such, it can take a while. Okay, container image built, and it's loading up. Again, I didn't actually run a timer, but that was not 10 seconds. So using the default, I make no configuration changes about my environment, just the vanilla Codespaces dev container base image. That'll spin up about sub 10 seconds or so. That was, I'm gonna say, maybe a minute or two, right? 3 tops, I feel. I've got no sense of time. So here I have the environment. I'm logged in, quasi-logged in. I don't want to say fully logged in, but I'm logged in as my own GitHub user account. I can do git pull. It's not going to do anything because I'm already up to date. I can do git push. Again, it's not going to do anything because I'm already up to date. But I've got all those commands automatically injected, for lack of a better way of calling it, into my environment already. Okay, so I don't have to worry about setting up Git. I can start working on my project right away. Okay, cool. So I don't have to install MLFlow. It's already done for me. It's specified to a certain version based on the Docker file. Wrong folder. If I go dev container, Docker file, MLFlow 2.10.2 as of this video recording. I'm on a Python 3.11 environment. I'm working as VS Code user at that time, which then installed mini-conda. I should have conda in here. Which conda? Yep, conda is there. Even though it's saved under a different user, which Python version, Python version, there we go. So it's actually 3.12.1. Why was that? Probably a different build that I was doing. All right, well, let's go with this. Again, we're doing this live. I should have run through this demo one last time before actually starting it up. All right, so first thing I need to do, if you've never run MLFlow, you likely will be starting up the MLFlow server or the tracking server. Documentation kind of goes back and forth, the UI server. There are a couple of ways to spin it up. I haven't done this only a handful of times, usually go the cheap and easy way, MLFlow UI. This starts up the tracking server, the model registry server, and it stores everything locally within this given directory and folder. The default port for this is 5000. If you notice, I have 5000 and 8080 already mapped from that remote environment onto my local machine. So in my web browser, I can actually open this up in a second as if it were local. Okay. If I go back to terminal, I'm just gonna hit enter. It'll start up the server. You notice here it creates my local ML runs sort of stateful environment here. So it'll track my runs. It creates a database of all my experiments. Okay, that's good to go in that sense. So it's local, again, inside the Codespaces. It feels like it's on my local machine. It's actually running remotely. In a separate terminal here, instance, I'm actually going to go back for a sec, go back to the MLFlow example repo. I want to run this project. It could be local to that, it could be local to this environment. Okay, I could have a separate projects directory in here and keep all my projects in there. It could be Python notebooks. It could be just straight Python files, up to you. I'm just going to run this particular example, so you can as well. I want to copy the HTTPS version of this. The reason being is because this is a public repo, one. So this work, I don't have to authenticate against it. Number two, if I choose the SSH version, one of the things that you should be aware of is that even though I'm logged in as myself here, there's no actual SSH key in this instance. It didn't generate one for me, because then I would have to include it under my profile in GitHub, and there's a whole setup that needs to be done. Instead, what it has done here is that, so let me just ls my .ssh folder doesn't exist. Like, I don't have any SSH configuration in here. Instead, what it's done as part of GitHub Codespaces is that it's bootstrapped this environment with a GitHub Personal Access Token, PAT token, in here instead. And so I can use HTTPS and be able to authenticate as myself with that username, etc. Push pull, and then grab things that I have access to via that way of authentication. All right, that said, there are a couple things I need to do. I've included in the README file. I might have to update this because I might have messed up. But MLFlow UI ran that in this first terminal. In the second terminal, I'll want to set up the tracking server URI, which, allow me to copy paste, is set to the local host, or local loopback really, 127.0.0.1, port 5000 on that remote machine, Codespaces machine. Hit enter. This is important because MLFlow will need to know, like, where is my remote tracking server? In this case, it's not really remote. It's local to the same environment that I'm running this in, but you could swap this out with, in future videos I will, Azure ML Studio. It provides the same interface UI to host a MLFlow server on your behalf. It could also be Azure Databricks. That also, of course, because the folks from Databricks created MLFlow, provides the ability for you to host the model registry, tracking server, etc. in there as well. Okay, so you need to tell MLFlow before you run the command, that indeed that is the server we're going to track everything to. Okay, the next step then is to actually run a given project. As I showed before, I'll go through it just quickly. The MLFlow project sort of YAML metadata format is like so. Yours might be more complicated. You may be running multiple files, entry points, etc. But this is, the slim basic version of it. It needs to be there. The files associated need to be accessible as well. But as long as I can run this, so MLFlow subcommand run, and then tell it which resource. This could have been, /projects directory / whatever project you're running. Again, in my case, it's going to be a remote Git repository. Hit enter. It'll do all the magic for me. Pull it in, install the Conda environment, all the requirements that are required for Conda to run, the packages, the version of MLFlow that it used, etc., that was defined in that Git repository. It will start running the experiment in here. It'll track the parameters that I passed in. It'll track and create the model, all that good stuff. Okay, that's like watching paint dry. We'll let it continue. And what I'm going to do now is to actually open up the MLFlow server UI, which is running in this remote environment. I can click on this open in browser icon. I could have set up a function to automatically, open up a tab in my browser. I've chosen not to do that. But I just click on that. What this will do is it's set up on my behalf the port forwarding to that environment for me. Okay, HTTPS, TLS connection, and it's showing me the actual run that is, looks like it's still occurring at the moment on that remote machine. So if I just go back to terminal, it's still running, it's still executing, doing whatever it's doing. Probably installing the libraries that are needed before it actually runs. Yeah, it's pip install, there you go. Perfect timing. And so it's still running, okay? All of this I get for free. In the sense that I just have Codespaces, I've got this dev environment. You notice that the format of this structure is the remote environment, this cuddly cod. So you notice that in my environment here is cuddly cod. There's some error, I'll check that out in a sec. Did it run? I think it ran. Check that out in a second. Cuddly cod is what the name of my Codespace. It is running cuddly cod, unique name, and then the port number that I'm actually forwarding to. There's a capability of only doing like a private session. Essentially, it's not public accessible. I'll show that in a future video, so that I can treat this fully secure. It's only done through SSH tunneling or HTTPS tunneling for my environment. Okay, let me do a refresh. This will show me. Oh, in fact, it failed. Something happened. We'll check that out in a sec. Ran for 1.5 minutes. I suspect this has to do with my Python version because I thought I'd fixed that, but I clearly didn't push the correct change earlier. In any case, had this succeeded, I can actually click on the run. There are no artifacts being stored in here, so there are no log data. There was no model that was built as a result of it. Click parameters. It shows me the parameters that I passed into that environment, any subsequent metric, which again, there weren't any in this case, etc. All of this for me for free. Okay. So that's great. I can also see where, like what was the source of my run? Like where did I get that from? In this case, again, it'll put me back to the public repo, okay, for it. Or it would have pointed me to like the local file to which that was running. I was gonna pause the video for a second just to determine where I messed up in setting up my demo environment and come back and rerun this experiment, hopefully to success this second or third time, right? All right, jump cut. Fast forward, try to figure it out. This is going to be a longer video than I expected, but I'm going to walk through what had happened, and I'll try to figure out how to fix this going forward. But some of the key things in here and why it's great to share and then solve through GitHub, source control. One key thing when doing this. While I'm doing it in practice for a quick demo, what had happened in the last couple of days is that the version of Conda that I'm using has been updated to Python 3.12, and that's February 27th. Prior to that, mini Conda was only 3.11. So I had to make some changes there in terms of the actual script I was running. So if I just go back to my Codespaces environment, MLFlow Codespaces, the dev container specification, the Docker file. I've actually pinned the mini Conda version here to 3.11. So better practice, best practice, good ethics in terms of doing this. Pin your version, whatever dependencies you're using, to a specific version. In my case, I had to pin my version of mini Conda for Linux to 3.11. So if I scroll down here, 3.11. So I pinned it to this version that's here, changed my install script into Docker, pushed that change, action kicked off, rebuilt the container image, and now new workspaces will reference that new image with the proper version of mini Conda. I did find, and I'm still trying to figure that out, and I won't, put the reason why in here. It'll be a subsequent video that I'll add in descriptions once it gets created, on how to actually fix one weird kind of situation that I'm in. So for whatever reason, the Python version still doesn't quite work. It's at 3.11.7, and then if I type which Python in here, it is using Conda in the web browser version, and it's using 3.11.7. This doesn't work. If I run MLFlow run and then to the example repository, it just doesn't go. I tried, because I had run it a few days ago. I can open up in VS Code on my desktop environment. It probably has to do with the bash profile setting. I'll figure it out. Anyways, as I mentioned before, you can actually attach your local VS Code setup. I'll just get out of the way here. Your local VS Code IDE to this remote Codespaces. So if you notice here, the hamburger menu, I can go to my Codespaces to choose one, or I can open up in VS Code Desktop or VS Code Insiders, whichever one you have running, and it will launch subsequently your VS Code environment on your local machine. Okay, so this is my version on my local desktop. Okay, great. So it's connected remotely, so remote development environment, attached to VS Code. If you notice, if I run Python version 3.11.8, okay, weird. Which Python, and it's using the system Python, so whatever Docker file itself had pinned to. Okay, neither here nor there. Again, another troubleshooting video. Was able to track this down. So what have I done? Off screen, I tested this. I ran an experiment. I've already exported the local tracking server, local host, local loopback address. Okay, cool. I ran this before a couple times. I want to run it again. But before I do that, go back to my browser. Here is the remote environment, super Eureka. I spun up a new Codespace with the updated versions, etc. Ran a couple different times. These are the ones on the, for whatever reason, the web version that's pinned to the Conda Python 3.11.8, those failed. Or 3.11.7, I can't remember now. I can't keep track of all this right now. Python version, so yeah, 3.11.7 is failing. Those are the failed ones, 3.11.7. Passing ones are 3.11.8. So I have to figure out why that is. What I wanted to show you, if these environments lined up properly, is I can actually run this experiment again. If I run it, most things didn't change, so this run will be very quick. Okay, done. And so if I update my UI, refresh it, 6 seconds ago, this is the one that actually loaded. So this is what I wanted to actually show you in terms of the UI, what you get for free if we actually run this in Codespaces. Okay, cool, right? I got a lot of this output. What was the actual, workload that actually ran? How did it run? What are the artifacts that got created, right? Or that we're leveraging? So here it shows you all the exact same stuff that was in repo, right? ML model itself that we generated as an artifact. We can rerun this. The pickle file, the actual model that gets created. What is the Python environment, 3.11.8, etc. This would probably run better because it's actually pinned, and so on and so forth. Okay, really cool. The parameters we put in, so it tracks that because we're logging it, and then we can see some metrics. So here we can see what that looks like. We can also see RMSE. It's only ran once, right? So it's this one large block over time. So we get all of this for free as a result. We could run in subsequent future videos something more complicated than this example repo, but again, we get all this full MLFlow environment. We can attach to remote Codespaces environment. We can create, stop, destroy. And so that's sort of phase one, the crawl scenario in terms of getting a development environment stood up for my machine learning workloads with Codespaces. And so once this runs, you'll notice that, we've been running for 30 minutes in this particular environment. We can shut it down to save time because perhaps the experiment ran correctly and we did what we needed to do. Okay, fantastic. So I am going to go back to my MLFlow, close this tab. I'm going to go back to my actual Codespaces project, which is this one, I believe. And Cuddly Cod, no, I was actually running in this environment, even though I shouldn't have. I can, actually before I do this, I'm just going to show you quasi what you could do at this point. I can go git add a git commit -m, ran my ML demo, right, to test out my experiment, just generically, right, just in terms of flow. And then I could, and that will save all of my run information, all the artifacts, all the various runs. So each of these directories represents, each subsequent run or experiments that I did, right? Some of them passed, some of them failed. It would correspond to the same thing in the UI, all right? And so what I can do now in order to save this is I can push it. I'm not going to in this case, but I could get push back up to my repo and be able to close the environment down, but still have access to this. This is still stored long-term on my behalf. So that's sort of the short of it. I'm not going to push because I don't want to pollute my upstream version of this demo. But under normal circumstances, and I apologize for my demo not going according to plan, that's generally how it would go. And I'll clean it up for the next video. Yeah, that would be the setup. Okay, great. We can create an environment quickly. We can run experiments to success. We've got a UI to track and see all the metrics. We can push all of that back to Git and be able to rerun it without having to set up a remote server and all that kind of stuff. So if I would say the best scenarios for this, if I'm a solo engineer, solo scientist, if I'm in perhaps academics and I don't have a compute cluster to use, and perhaps the laptop that I'm using is overburdened, I'll put it that way, and perhaps isn't powerful enough to run my workload, I can get this set up. And because this is treated as an ephemeral environment, let me just go back to my forked version so I can shut down. Actually, I think it was in here. What I can do instead is I can actually just destroy my environments. Okay, so what I'm going to do here is I want to destroy all of these ones. Let's presume this was the one I was working on. Actually, Organic Spoon was the one I was working on earlier. That was good for my demos. I want to just start deleting these environments, okay? Presuming that I pushed my changes, right? I'm not deleting one that hasn't had the changes pushed upstream. I can get rid of these environments. I can actually just stop them, just to stop. I can stop the code space. So this stops the billing or the free compute time. I get up to 60 hours with 2 cores, and it reduces by half depending on the more cores that I add. So it goes to 30 if I have a 4-core machine, and so on and so forth. It goes 8 to 16. I can just stop the environment. This doesn't delete it, so stopping just stops the machine. Or I can altogether delete it if I really don't want to keep that around. Like, it's not pertinent because I could have pushed my changes to my repository anyways. So I'm just going to clean up, delete those environments because I don't need them. I'm going to, these are main quasi-fixed changes. I'm going to delete that. It's like watching paint dry, right? You're watching me actually in the environment. So this is the one I was just working on. I can stop it, which is what I'm going to do. I'll stop that environment. That will, unfortunately, right? So I stop the environment, right? It'll stop my remote session. All of those changes, mind you, right? Like, let's say I didn't push it. The safe thing to do is to stop my machine and not to delete it until I'm 100% sure. Stopping it just stops the compute. Everything I was working on in that environment is still saved inside that machine. So I didn't do an actual push. The commits are still there. The push is in that particular instance, but it's not reflected in my actual repo here. Okay? Cool. So I can actually start it up again. I can either hit start here. I can open up the command palette in here and start my code space. I can actually go back into Codespaces here and where's start again? I can just actually click on that instance and it'll reboot that machine on my behalf behind the scenes. And then the clock is ticking again in terms of the amount of compute I have. All right. So that's the cleanup portion of it. This is great. So what I want to go into now in this sort of final stretch is to discuss the pros and cons of this. Pro, okay? First column, pro, quick to get started. I can programmatically codify, script my environment, all the necessary tooling I have. I can share it amongst peers. I can share the full environment, okay? I can share the actual project runs, etc. It's saved in that environment. It's very minimal setup. I can, consume or use as much as I need to, and it's great for demos and learning. I highly suggest this again if you're in academic field. This is, I think, a fantastic option. If you are in an enterprise, or if you're doing this in a fully shared environment, this is where the cons kind of come into place, right? It's quote unquote local. However, as you noticed before, if I deleted the environment, I didn't commit the changes, I'm kind of in a sticky situation. If I stop the code space, that's cool. I can spin it back up and then commit my changes and save it to my remote Git repository. But it's not an ideal situation in terms of sharing, because there is a very high chance that if I'm trying to work in a distributed team running against this, that I could potentially clobber my peers' work. Now, the good thing about MLFlow is it actually tracks, as you noticed earlier, via unique IDs in terms of the experiment runs and things like that. So the chances of those collisions are low, but still, it's not the ideal path to do so. So sharing in that sense is a little bit harder. It's all writing to sort of the quote unquote local file system. And it can become messy. I'll put it that way. The most ideal path, and what I will start showing in video 2, is in fact the setup with this sort of remote environment with Azure ML Studio, or perhaps Azure Databricks, or your Databricks environment, and connecting, instead of that local host port 5000 for the ML tracking server, you'll connect to Azure ML or Databricks cluster instead. So that kind of combination of, I can still have this quick to spin up local environment that knows or is aware of with credentials to connect to a remote server, full-on remote server. My environment can be created and destroyed without much fuss. I can use as much compute in that sense as I want to. And then I've got this centrally managed compute cluster that perhaps my IT team or my project lead or management has control over, right? Security concepts or concerns and the security model around the cluster can be built as well. All right. So subsequent videos, again, we'll spin that up. We'll show how to connect to it, and then eventually we'll get to a point where we can actually deploy all this into a production compute environment and take advantage of all of it. Right. So yeah, thanks for sitting by. This video was a lot longer than I had planned on it, and I will also try to follow up with a video that walks through the troubleshooting process in terms of setting it up and why there was that quirk. But that'll be out of band of the series itself. All right. Thanks for your time. Thanks for sitting through all of this. Hopefully you learned something and this was useful. Please leave any comments that you might need about the video, or if you want to see this taken in a different direction. Yeah, great. Thanks again for your time. Take care.